Hello, everyone. Hope you all are doing well. This is Caleb Gitlitz, Eliav Hamburger, and Alma Mohammed here presenting Tattoo Regret, courtesy of Dr. Copeland. So, a lot of people suffer from tattoo regret. Luckily, we Jews don't really have to worry about that, but a lot of other people do. And so, there is a tattoo removal shop in our story called What Were You Thinking? Because, that's sort of what your conscience asks you when you make decisions you regret. And so this tattoo removal shop has a rate that models that tattoo removal over 10 minutes, over 15
months,
called R of T. And while T is greater than 0 but less than 6, R of T is equal to -2 T cubed plus 12T squared plus 24. Next part of the graph is linear from 6 to 8. And then, so the slope for that equation is going to be -6, because what you do is you have to take y2 minus y1 over t2 minus t1. So y2 is 12 minus y1 is 24 over 8 minus 6. That gives you -12 over 2. That's -6 for your slope. And it's -6 tattoos per month squared because the rate is measured in tattoos per month. So now we will just plug that into our y equals mx plus b. We will take the point 812. So y12 is equal to m, -6, times 8, which is our x, plus b. So 12 is equal to -48 plus b. Then you add 48 to both sides. 12 plus 48 is equal to 60. So our b is going to be equal to 60. For our full equation, r of t, while t is between 6 and 8, is going to be -6t plus 60. Remember that, we'll need it for later. And then for t is greater than 8, but less than or equal to 15, then r of t is going to be 3 times the quantity of t plus 1 to the 3/2 minus 69. And here's our graph for your convenience. All right, just to recap, function r of t, let's look back at our graph. R of t is equal to -2t cubed plus 12t squared plus 24, from inclusive 0 to 6 exclusive. R of t is equal to -6t plus 60, 6 to 8 all inclusive. And then from 8 exclusive to 15 inclusive, R of t is going to be equal to 3 t plus 1 to the 3/2 minus 69. Part A, find r prime of 7. So we need to find the derivative of r of t on the interval 6 to 8. Luckily, that's the linear part. So r of t is equal to -6t plus 60 between 6 and 8 inclusive. So the derivative of r of t is equal to -6. Because r of 7 happens to be between 6 and 8, and r of t is equal to -6 tattoos per month squared the whole time, then r of 7 is also going to be equal to -6 tattoos per month squared. That's r of 7 because it's on the interval 6 to 8, and it is just t to the first power in our r of t. So our prime of t will give us -6 the whole way through. And now on to part B.
All right, so for part B, we have to answer this question. For the time interval between 0 and 15, at what time t is r increasing at the greatest rate? Show the reasoning that supports your answer. So it's important to remember that r of t is the rate of tattoo removal per month. There's already a rate. What they're asking is, when is this rate increasing at the greatest rate? So the question is, when is r prime of t, when does it have the absolute maximum? And so the way we find this is using the first derivative test. So what we're going to do is we're going to go piece by piece. There are 3 pieces to this function. So we're going to go 0, 6, 6 to 8, 8 to 15. We're going to find the first derivative and the second derivative. Then we're going to take the second derivative. We're going to set it equal to 0 to find the critical points. And at all those points, r prime of t could have a maximum or a minimum. And then we have to use the first derivative test on r prime of t in order to find out whether it's a maximum or a minimum, and then figure out which one is the absolute maximum. So it's just the first derivative test on the first derivative. So the first thing we're going to do is we're going to start with a piece that goes from 0 to 6. R of t is equal to -2t cubed plus 12t squared plus 24. This is very simple derivatives. You just multiply 3 times 2, and you subtract 1, and you do the same thing for 12t squared, becomes 24t, and then you get rid of 24. and you end up with the derivative of r prime, is negative 6t squared plus 24t. And you'll notice I'm using what are they called? Parentheses, not brackets, because we're going to test the endpoints later because it's the first derivative test. And then we're going to do the second derivative, and you're going to do the same thing you did, multiply 6 times 2. You're going to get rid of the t for the 24, and you're going to end up with negative 12t plus 24 is the second derivative. Now we're going to set the second derivative equal to 0. And this one's pretty easy. You can see that t is equal to 2. So our first critical point is going to be at 2 months. Now we're going to move on to the next part. We want to know if there could possibly be a maximum of r prime on the next piece of the piecewise function, which if you recall is from 6 to 8. But we know the derivative of r prime is going to be negative 6 at all points between 6 to 8, because if you remember, r is linear at this point and it's decreasing. So since that line is always going down, since the derivative is always negative 6, we don't have to consider any of the points between 6 and 8 because we're looking for when it's increasing at the greatest rate, and here it's decreasing. So it's completely irrelevant to the problem. It's not going to be a maximum of r prime of t because it's decreasing, it's negative 6. So now we're going to move on to the third part, the last piece of our piecewise function. So this last piece from 8 to 15 is going to be r of t equals 3 times t plus 1 to the 3 halves minus 69. And so the way you're going to do this is you can multiply 3 by 3 halves, and then you're going to subtract 1, which is to become 1 half. And then you have to multiply that by the derivative of t plus 1, which is easy. It's just going to be 1. And then you're going to get rid of 69 because it has no variables. So when it gets derived, it becomes 0. And you're going to get r prime of t is equal to 9 over 2 times the square root of t plus 1. And then you're going to treat that as a 1 half. And you're going to do the same thing again. You're going to say 9 over 2 times 1 half. You're going to get 9 fourths. And then you have to subtract 1 from 1 half. And you're going to get negative 1 half. And so our double prime of t is going to be 9 over 4 times the square root of t plus 1 in the denominator. And so when you set this equal to 0, you're going to notice that this function can never be equal to 0, right? Because 9 is 9. It's not going to ever be 0. But the denominator can be undefined. When t is negative 1, what's under the radical is going to be 0, and the square root of 0 is 0, and 0 times 4 is 0. And then you would have an undefined function, or an undefined value, because you can't divide by 0. So at t equals negative 1, we would have a critical point because it's undefined at that point. The only issue with this is we can't have time being negative 1 month. We don't have negative time. The graph starts at 0, it ends at 15. So we can pretty much disregard this because there are no critical points on this piece of the function, at least not in between. We're going to test the endpoints later. Okay, so now that we have our critical points, our only critical point, which is t equals 2, we have to do the first derivative test on this. So if you remember, what we do is we take the derivative of that function, so r double prime of t, and we see if the function goes from negative to positive, which would indicate, from negative to positive, which means it would go, r prime of t would go down and then up, which would be a minimum, or whether it goes from positive going up to negative, which would indicate that it was a maximum. So the first derivative test on r prime of 2. So r double prime of 1, we have to choose a point before 2 and a point after 2. So we're going to use 1 and 3. So r double prime of 1, if you plug it in, it's going to be negative 12 times 1 plus 24. And that's going to be 12 tattoos per month cubed. That's the unit. So 12, so it's positive. So we know that it's going up at the beginning before it hits r prime of 2. And now we need to test r prime of 3 to see whether it's going to go down or if it's going to continue going up. So r prime of 3, negative 12 times 3, which is negative 36 plus 24 is negative 12. So we know that it starts going up at 12, or at r double prime of 1, and then r double prime of 2, we know the slope is 0, and then it starts going down at negative 12 tattoos per month cubed. So we know that r prime of 2 is a maximum. So it could be the answer to this question. 2 could be the answer. But now, before we decide that that's the answer, what we have to do is we have to test all the endpoints of this function. So 2 months is a maximum of r prime of t. But before we continue, I wanted to show you a handy graph of r double prime of t. So this will kind of explain to you what we were doing before when we were using the first derivative test. So at r double prime of 1, you can see that the graph is positive, which means that r prime is increasing. And then at r double prime of 2, it's 0, which means the graph of r prime levels off. And then at r double prime of 3, it's negative, which means r prime is decreasing. So the graph of r prime increases up until 2, levels off, and then starts decreasing, which indicates that it's a local maximum. Now we have to figure out whether it's an absolute maximum. So now that we have our critical point, we know the value, what we have to do is we have to test the endpoints. And since this is a piecewise function with 3 pieces, there's actually 4 endpoints we would theoretically have to test. We have to test 0, 6, 8, and 15. So let's start with 0. Let's start with 0. R prime of 0, negative 6 times 0 squared plus 24 times 0, that's 0. So it could theoretically, I guess, be a maximum, but it's not even increasing. It's just going at 0 at that point. So probably not. And if you recall what our graph looks like, this linear section has a sharp turn at 6 and a sharp turn at 8. So since there's a sharp turn here, the derivative actually doesn't exist here. It's discontinuous. So we actually don't have to worry about that being a maximum. So at 6 and at 8, it's a sharp turn. So we can just ignore them as possible maximums. The last one we have to do is r prime of 15, which 9 over 2 times the square root of 15 plus 1, which is 16. So the square root of 16 is 4, and 4 times 9 over 2 is going to be 18. So now we have our r prime of 0, our r prime of 2, which was our critical point, and our r prime of 15, which is 18. So now let's find out which of these is the maximum. So just, we made a little handy dandy graph on Desmos. This is our derivative. So the derivative of the piecewise function. So if you had this beginning, you could just see graphically where the maximum is. So you'll see right here, it's actually at 2. It's the highest point of r prime of t, which is what we're looking for. So now let's go through it. R prime of 0 is 0. So that's the point right here, 0, 0. Our next one is r prime of 2, which is 24. You can see it right there at the top of the red line. And the last one is r prime of 15, which is 18, which is all the way at the end of our function. And as you can see very clearly, 2, 24 is going to be the highest point on this function. It's our critical point. It's the maximum. And therefore, t equals 2 is going to be the point at which r of t is increasing at the greatest rate. So 2 months is our answer. So that's going to be the end of part B. The next part C, we have to find the average number of tattoos the shop removes per month from 0 to 15. So what we're going to do, and this is a calculator active problem, so I have my calculator out here, and I'm going to ask you to also find the integrals along with me. So get your calculators out. I don't know if I should wait, no, whatever, you'll figure it out. So the way we're going to do this is we're going to integrate each piece of the function to find the area under the curve, and we're going to add them all together and then divide by 15 to find the average per each month. So here's our little graph. We're going to find the area under the red part, under the blue part, under the green part. And we're going to divide by 15. As you can see, the graph goes to 15. So the first integral is from 0 to 6 of negative 2t cubed plus 12t squared plus 24 dt. That's obviously the first piece of our piecewise function. And you should type into your calculator now. I'm going to do it alongside you guys so I can figure out how long it would take. So do that now. All right, hopefully by now you've got the answer. I'll give another 5 seconds. The answer is 360, you guessed it. And now the next piece we're gonna do is from 6 to 8. If you remember, that's gonna be linear, so this is a real easy one. I mean, if you want, you could even evaluate it as a polygon or as a triangle with a square below it, however you want to do it. We're going to do the actual integral. Ready? Negative 6t, hold on, from 6 to 8 of negative 6t plus 60 dt. And you should get 36. Now, the last one is going to be from 8 to 15 of 3 times t plus 1 to the 3 halves minus 69. So 8 to 15. Make sure you put your 3 halves. If your calculator doesn't actually go up, put it in a parentheses so it knows that that's all part of the exponents. And you should get the answer 454.2. And now what we're going to do is we're going to add all the values together. So 360 plus 36 plus 454.2. And that's going to be equal to 850.2 total tattoos. So that's our total. Now we have to find the average. So 850.2 divided by 15 is going to be equal to, take out your calculator, by 15, 56.68 average tattoos per month. And that is going to be it for my part.
So for part D, we are given a new rate, R of T plus K, where the average is 75 tattoos per month over the time interval 0 to 6. And now we are asked to find K. So given that the new removal rate is R of T plus K, we're going to use the formula for the average rate of change. And we're going to have an interval from 0 to 6, R of T plus K dt over 6 equals 75. And from there, we're going to try to solve the equation. We're going to split up the two integrals, and we're going to have 360 plus 0 to 6 k dt over 6 equals 75. Now we're going to try to solve for k from the interval of 0 to 6. And we're going to have 360 plus 6k over 6 equals 75. From there, we'll simplify and get 60 plus k equals 75. And thus, K is equal to 15 tattoos removed per month, and R of T plus K is R of T plus 15. So now what we've covered calculating the slope of a line from 2 points, derivatives of a piecewise function, the first derivative test, integrals of a piecewise function, averages, and calculating the value of a constant based on how it affects the average. All from the lens of a tattoo removal shop. We hope you enjoyed.